Alright, calculus, we are looking at section number 30 here from your workbook. It is the U substitution with the fundamental theorem. So how is this different from what you guys did before? Well, we looked at things like, for example, what is the square root of x minus 1 dx? And we looked at just the indefinite integral where these lower and upper limits were missing. There was nothing there. It was an indefinite integral. And we would have said like u equals x minus 1 and then worked our way from there. The catch now is that we're going to put numbers here. So, for example, let's say we said from, I don't know, 2 to 5, that kind of thing. Then we can calculate that. We can plug those values in and calculate them. And this u equals x minus 1 substitution is going to affect these numbers as well. So we're looking at how it affects that upper and lower limit. That's the big idea. Let's play it out. So as we look at the first thing here, it's not too crazy to do a u substitution. That's pretty normal. I'm going to look at some of these things. We have this stuff down here that has balancing, but I'm not really going to look at that one so much. I'm going to just kind of take it step by step. So I want you to ignore that for now. So let's see what we have. What is u? Well, when we look at this, we always looked at layers. And the inside layer was our u. So if you were to try and break this down, what's the inside layer? It looks like it's this x squared plus 1. Okay, not too hard. We have that in there. So let's see what we have. U equals x squared plus 1. That was easy enough. Du then. So what's du? Well, when we take the derivative of that, we kind of do this the long way a lot of times, but du dx, if we were to take the derivative of both sides, equals 2x. So another way of kind of rewriting that is du over 2 equals x dx. So if we can find an x and a dx, these two terms here, just like this term here and this term here, then we can take those out and replace them with the du over 2. And we're going to replace this x squared plus 1 with a u. Well, let's do that. We're going to take this thing and we're going to replace the x squared plus 1, which is this inside piece. That's just u. It's still squared here. And then the other two pieces, the x dx becomes du over 2, or in other words, 1/2 du. Alright, so good so far. And if we were to look at this, we said du over 2 equals x dx. Do we have it? Well, now we do. We've set it up. It's like, check, yes. Okay, here's the catch. Where did this 2 and this 0 come from? They came from the top and bottom limit here, from the lower limit and the upper limit, the interval that we're taking the integration over. So if x equals 2, now remember that u equals x squared plus 1. So I'm going to plug in this x equals 2 into that and see what that would be in terms of u. That means it's 2 squared plus 1, or 5. Similarly, if I put in a 0, that's 0 squared plus 1, and that equals 1. So now what I'm looking at for my lower and upper limits is, instead of this saying x equals 0 and x equals 2, now it's going to be u equals 1 for the lower limit and u equals 5. So not only do we have to go through and change all this stuff on the inside, I also have to change the other pieces, the top and bottom evaluations there. Okay, so we got an easy problem. It says 1/2 u squared. So that 1/2, it's a constant. Constants, they float in, they float out, they don't really get affected. They just kind of hang around. I call them tag-alongs a lot of times. So it's going to tag along. So we still got this 1/2 here. And the u squared going to become u cubed over 3. And then we're going to evaluate that from 1 to 5. Now here's another, small difference. I didn't have to change this back into terms of x. I could have, if I wanted to, in terms of, so this is in terms of u. If I were to change this into terms of x, we'd still have the 1/2, and instead of u it would say x squared plus 1 cubed over 3. And these limits from top and bottom would also be in terms of x, 0 and 2. So this is x, 2 equals x, 0 equals x. But I can just leave it in u because I'm going to substitute numbers in there and calculate that. And I want to show you guys that I come up with this same value for these. So this is going to be 1/2 times 5 cubed over 3 minus 1/2 1 cubed over 3. Actually, I shouldn't do that. It's 5 cubed and then over 3. That 3 on the bottom is not cubed. So I was just thinking multiply here, multiply here. All right, so let's look at this other one. This would be 1/2 times 2 squared plus 1 cubed. Let's erase a little bit of this. Give ourselves some space here. 2 squared plus 1 cubed, quantity cubed, over 3, minus 1/2 0 squared plus 1 cubed over 3. And if I were to simplify those values in the parentheses, I would have 1/2 5 cubed over 3 minus 1/2 1 cubed over 3. Notice something. Same answers, whether it was in terms of u or terms of x. So when you have that balance, when everything is translated, you don't have to take it back into x. We are good here with the u's. So just to simplify this, just to finish out the evaluation, 5 cubed is 5 times 5 times 5. That's 125. And this is going to be 1/2 and a third. That's going to be over 6. And then we're subtracting from that 1 over 6. So we would get 124 over 6. Now I know a couple of things about this. I know that both of these are divisible by 3. Or no, they're not both divisible by 3, but they're both divisible by 2. This top one would become 62. And the bottom one would become 3. So if I were looking at this, as a simplified final answer, that would probably be what I'd write down for a multiple choice test. Of course, up here, this is FRQ level. You didn't have to simplify all the pre-algebra stuff. You're good there. This would be your multiple choice type answer. Okay, let's do some more of this. Let's keep practicing this idea. So, example 2. All right, we just got to kind of practice through doing all these substitutions. Remember, right up here we have this is x equals 0 and x equals 1, so we got to take care of those as well. Let's figure out what u equals. In this case, u is going to be the inside layer, which is 1 minus x squared. And then if I want to take the derivative, I would have du dx equals negative 2x. I notice up here that I have an x dx. So I need that x there, but I don't need the negative 2, so I'm going to swap the negative 2 and dx. Doing some algebra here, you would get du over negative 2, or negative 1/2 times du, equals x dx. So now I can substitute those two pieces out as well. And remember that square root really means something to the 1/2 power. That's going to make it a little bit easier for us as well. Alright, and I got my limits. So my limit up top here, if x equals 1 and u equals 1 minus x squared, that's going to be 1 minus 1 squared. And then if x equals 0, u is going to equal 1 minus 0 squared. Well, the top one's going to be 0 and the bottom one's going to be 1. That's kind of interesting. They actually kind of switched places there. That happens. So, and by the way, this was my top and this was my bottom. Keep that straight, because even though we have the same numbers that we started with, they swapped places. So that means that my new integral is going to be from 1 to 0, and I need a negative 1/2 in here. I need a negative 1/2 and a du. And then the substitution that we're making, it's u, but this power here, this square root, means it's going to be u to the 1/2. All right, we've done the hard part. Now it's just doing some of the math. Well, let's work our way through this. So the antiderivative of u to the 1/2, we're going to add 1 to the power. That gives me u to the 3/2, and then over 3/2. And this negative 1/2, it's a constant, so that kind of stays there. Not kind of, it actually does. Because we could pull it outside of the integral, do the integral, then put it back on. It's a tag along. We're evaluating this from 1 to 0. Okay, I'm going to take this a little bit further, simplify that fraction there in the denominator. That would give me negative 1/2 times 2 over 3 times u to the 3/2. Keep in mind that these 2's would simplify. So now we're really looking at negative 1/3 u to the 3/2 evaluated from 1 to 0. Okay, we're still going here. We got to do the top values minus the bottom values plugged into the whole function there. So the top value is going to be plugging in 0. So that's negative 1/3 times 0 to the 3/2. That's going to be 0. Minus the bottom ones, we plug in negative 1/3 times 1 to the 3/2, which is really just 1. So this first term is 0. Then I got minus negative 1/3. That minus negative, we don't like the double signs, it changes to a positive. So it's going to be 1/3. Excellent, excellent, excellent. Okay, pause the video if you need to take note of that, because I'm moving up and doing the second one, example 3. Alright, so talk to yourself for a second. Make yourself a little crazy, I guess you could say. There's a couple of things that we need to take care of. First, I noticed that I have this inside layer. I also noticed that I have this 1/2 power, and it's on the bottom. So I'm going to do a couple things. I'm going to look at this as x times x squared plus 4 to the negative 1/2. I'm going to go ahead and take care of that power just so I can track my work a little bit better here. Make sure that I don't have to take care of it later. Now I could have done the u substitution and then worked it up, same idea. But I just wanted to get it done there. So let's talk about u. U. So what would u be? It's that inside layer again. U, in this case, is going to be x squared plus 4. So that's cool. That takes care of that part. Now notice I have an x and a dx here, so that means I got to take care of my du dx. So du dx is going to equal 2x, and that 2 keeps coming out. We keep having to get rid of it. So this would translate to 1/2 du. If we divide both sides by 2, multiply both sides by dx, 1/2 du equals 2, or not 2x. Whoa, back that up. X dx. Now we are set. We have our x dx. We got our u on the inside layer. And all we got to do then is translate these. So if x equals 5, then u equals 5 squared, square root of 5, pardon me, squared plus 4. Well, square root of 5 squared, that's 5, plus 4 equals 9. And then u for the bottom is going to be 0 squared plus 4, which is 4. So we got 4, we got 9. Well, let's make these adjustments now. We have an integral. That part didn't change. But our limits did. Now we're going from 4 to 9. Our u on the inside layer is now u to the negative 1/2 instead of x squared plus 4 to the negative 1/2. And we need a 1/2 and a du to balance the constants there. All right, easy breezy. So simple power rule here. u to the negative 1/2, we're going to add 1 to that power. It becomes u to the positive 1/2 over 1/2. And then we got this 1/2 constant out front. That's kind of interesting. 1/2's all around. And we're evaluating that from 4 to 9. Okay, think about this for a second. It's not too hard, but just to kind of see what you're doing. We have 1/2 and 1/2. When I flip that other 1/2, it's going to be even more obvious. Those are reciprocals. You multiply them and you just get 1. So all that we're going to see then is u to the 1/2 from 4 to 9. Now if I wanted to do top minus bottom, I can squeeze that in here. That gives me 9 to the 1/2 power, or in other words square root of 9, minus 4 to the 1/2 power, square root of 4. So that's 3 minus 2 equals 1. That's crazy how it comes out simple like that, with so many complex layers on top. Okay, again, pause the video if you need to catch this, but we are moving on. Next. Okay, so it's not exactly obvious, but it should be a little bit of a challenge here. So notice that you do have two layers. We got this inside layer of 2x in here. And then we got an outside layer of sine. Now, a sine of something is not a big deal. But having that 2x in there, that kind of makes this a little bit harder to deal with. So let's take care of it by giving it a u substitution. U equals 2x. Keep in mind now we're going to have to figure out what the dx has for us. So that means du dx is equal to 2. Okay, so if I took the derivative of that, I got du dx equals 2. Well, I can multiply dx to both sides, divide 2 for each side, and I get 1/2 du equals dx. So I have the dx here, but this 1/2 is going to be added in. Let's look at the limits. So if u equals 2x, that means that up here u is going to be 2 times pi over 4, which is really pi over 2. And for the bottom, u is going to be 2 times 0, or that's still 0. That was easy enough. Alright, let's make all our substitutions, see what we have left over. That means I'm going to go from 0 to pi over 2. Let's use some color like we have been. 0 to pi over 2. And this sign, that's going to be the same. It's still sine. That did not change. But now on the inside here, this is u. And we need a couple other things because we need a 1/2 and a du. So we need a 1/2 out front and this du. Now we are set because we can do the antiderivative of sine. In other words, the derivative of what equals sine of x. That would be negative cosine of x. So what are we going to get here? This is going to be negative cosine. Remember, we're still in terms of u here, of u. And we're evaluating this from 0 to pi over 2. So I got to figure out what's cosine pi over 2, what's cosine 0, plug them in, see what we get. Let's do that. Top minus bottom. That's our fundamental theorem of calculus part 1. You plug in the top functions into the top value into the antiderivative, and then subtract the bottom value in the antiderivative. And then you see what you get. So you plug in the top value. That's going to give me negative cosine of whatever negative cosine pi over 2 is. So that's our top, minus our bottom. So that's going to be negative cosine of 0. Well, cosine pi over 2, that's 90 degrees straight up, so cosine would be 0. So that's a negative 1 times 0, or just 0. Then we have minus negative. Well, cosine of 0 on the other end is 1. 0 minus negative 1, put that together, make it a plus, it equals 1. It's crazy. These complex calculus problems have answers like 1. Alright, let's look at this next one. So we got sine of x, we got cosine of x. There's a little bit of an issue here. The primary issue is that one of them looks more complex than the other. And I can see that by this symbol here, this extra square root. So I'm going to use that piece for my substitution. I'm going to get rid of the complex part that has layers to it. That would mean that the inside layer in this case is cosine x. Okay, now let's start talking about the derivative of that. Well, du dx, taking the derivative of both sides, it's going to be negative sine of x. Now I want that negative in there. I want that sign in there, but that negative isn't really helping me. So that tells me that negative 1, if I multiply both sides by negative 1, and both sides by dx, so I'm going to get rid of this dx over there, but move it over here. And then I'm also going to multiply by negative 1 to make this and this positive. And then over here I multiply by negative 1. That gives me negative 1 du equals sine of x dx. Now I got my two pieces that I can pull out here. And recognize again that this layer, u, for the cosine of x, is going to be a square root of u, or u to the 1/2. Alright, now let's talk about limits. For the limits, we have pi over 2 and 0, but those are in terms of x. So if u equals cosine of pi over 2, well, we learned from the previous problem that we just did that that's 0. And then for the bottom, similarly, u equals cosine of 0, which is 1. Again, recognize that even though we translated, now it looks like we're almost going backwards with our area because we're starting at a higher number and ending at a lower number. So when I translate this, it looks like it's almost upside down. So I'm going to go from 1 to 0, and this is in terms of u. Now we're translated. So let's put our u in there. We have u to the 1/2. And then we have this du and the negative 1. So I need a negative 1 in here and a du. Alright, so let's calculate this. So u to the 1/2 is going to become u to what power? So we have 1/2, and then when you add a degree to that, it's going to become u to the 3/2. Don't forget to divide by that number as well. And it's multiplied by negative 1. Then we're going to evaluate that from 1 to 0. Okay, so I always like to write this out, top minus bottom, just to get myself organized. You don't have to, but I like it. Remember, this 3/2 is really 2/3, and that's negative, so it's really just negative 2/3 of that top piece minus negative 2/3 of the bottom piece to the 3/2, of course. So the first one, the top one, is 1. Oh, no, it's not. It's 0. And the bottom one is 1. So that gives me 0 for this first term minus negative. Well, 1 to the 3/2 is 1 times 2/3 is just 2/3. So we add these together, and that gives us positive 2/3. Easy, super easy, because we used u's. Okay, let's see what else we got. Looks like we're finishing with one last set of examples here. So for example 6, we got some interesting things going on, but it's a lot easier than you would think. A lot easier. Okay, so let's see what's happening. I have a 1 and then a sine of x cosine x dx. I'm going to split this up into two pieces because I think that constant 1 is actually going to make this, pretty straightforward, pretty easy for me. So I'm going to have the integral from 0 to pi over 6 of 1 dx. Notice that I'm not translating this one. I'm leaving it in terms of x. But for the other one, we are going to translate that one. It's plus, then we got sine of x cosine of x dx from 0 to pi over 6. Okay, you got choices. One of these needs to be u, the other one needs to be du. And when I'm trying to make this choice, I'm thinking that the derivative of sine is cosine. And if I were to do the derivative of cosine, that'd be negative sine. So then I would need a negative in there. So instead, I'm going to call sine of x, this is going to be my u. I'm pretty sure that cosine of x dx is going to be my du. But let's double check. So if u equals sine of x, all right, now let's take the derivative. Du dx equals cosine of x. Do some algebra here, multiply both sides by dx. And there we go. Du equals cosine of x dx. We're in the clear. But now I need to, adjust my limits. So up here, u equals sine of pi over 6. And if you're thinking about your unit circle there, that means we're up 30 degrees. So that's going to equal 1/2. Similarly, down on the bottom, u equals sine of 0, which is just 0. All right, so we got all our pieces. We have our upper limit, we got our lower limit, we got our du's and our u's. Let's calculate them. This is going to be the integral from 0 to 1/2 of just u, which in this case is sine of x. And then cosine x dx is our du. Super easy. Super duper easy. Because this is u to the first power. That simplifies, or the calculus now will give us u squared over 2. We're going to evaluate that from 0 to 1/2. And remember, because I translated these things into u, that means that I don't have to go back. I would get the same thing if I translated everything back into x, including the limits. So u squared over 2, that's going to be 1/2 squared over 2, or in other words, 1/2 of 1/2 squared. So let's write it that way. That might make it a little bit easier to read. This would equal 1/2 times 1/2 squared minus 1/2 times 0 squared. Well, the second term is 0, no problem. First term is 1/2 squared, that's 1/4, times another 1/2, 1/8. That would be your final value. Next one, example 7 here. We're going from -2 to 2 of the absolute value of 1 minus x squared. Okay, so this is a little bit different. We're talking about the absolute value of 1 minus x squared from -2 to 2. When I look at this, I see a couple of things. If this says 1 minus x squared, I know that that's going to be a symmetrical graph. And that's actually going to help me a lot in terms of visualizing this. But let's just take it purely from a u substitution, see how that works for us. So u would equal 1 minus x squared. Well, that's not too bad. And then what would du be? Well, let's figure that out. Du dx would be -2x, and then what else do we got? -2x. That's it. So then I'd have to multiply both sides by dx. And I'd have du equals -2x dx. Okay, this is where I start running into some issues, because I'm looking at this and it's asking me to take this derivative, the absolute value of 1 minus x squared, from -2 to 2. And if I were to try and do a u substitution, because I have this inside layer, it's kind of a problem for me. So in reality, I need to consider, what does this visually look like? Well, I'm going to use my calculator here for those of you that are a little uncomfortable with just going from scratch. So we're talking absolute value from -2 to 2. Well, absolute value is in the math menu, so if I go to math and then it's under num, so I'm going to scroll to the right once. And there's ABS, absolute value. So I'm going to type in here 1 minus x squared. Now I want to graph this, so I'm going to put my window from -2 to 2. Going from 0 to 10, that should be plenty. Okay, so there's our graph. And we want to integrate that area underneath. But there's a couple of things that I noticed. If you look at this, this is very symmetrical. Very symmetrical. So instead of having this absolute value 1 minus x squared from -2 to 2, that's the same thing as saying from 0 to 2 and then just multiplying your answer by 2. There's another thing that's kind of happening here. And it happens right here at 1 and at -1. So in reality, this graph has a bunch of different pieces. Let's go ahead and I'm going to pull this graph over here so you guys can see exactly what we're looking at. So right here, it hits the x-axis at x equals 1. Same thing at -1, which makes sense because if I plug those into the original equation, 1 minus x squared, so 1 minus 1 squared, that would be 0. And 1 minus -1 squared, that would also be 0. So that gives me these 2 points here. Now what's not exactly obvious is that if it didn't have the absolute value, this line would not be curved concave down, it would be concave up in between these two things here. So I have kind of a piecewise function. And this is what I'm really looking at doing. So I'm going to split this up into 3 zones. Here they are. Here's our first zone. And so that's zone A, let's call it. Then here's zone B, and here's zone C. And what's going to happen is for A, that's going to be the integral from -2 to -1. And the function is just normal. It's just 1 minus x squared. But then from -1 to 1, we're going to have the flipped version here. So that would be -1 minus x squared. Quantity 1 minus x squared. So it's going to change all the signs in that. And then the third one is going to be, again, regular here for part C. So that's A, then B, and now we're in part C. Part C is the integral from 1 to 2 of 1 minus x squared. So I got now maybe a more detailed version of this. It's got a lot more writing, but it's simpler to do as far as calculus methods go. So let's work our way through this. Notice I don't even need U substitution for this. Didn't have to use it. And honestly, I think this way is a little bit easier to understand, a little bit easier to follow. So for the first one, I need the antiderivative, and that would be x minus x cubed over 3. And we're going to be evaluating that from -2 to -1. Plus the second one is going to be the negative, so that's really -1 and then plus x squared. So we're going to have plus -x plus x cubed over 3 from -1 to 1. And then the last one is going to be plus. Now we're back to that other first antiderivative. It's the same as the very first one. X minus x cubed over 3. We're going to evaluate that this time from 1 to 2. All right, let's see what happens with some of these values. I have a feeling that some things are just going to kind of get duplicated here. So the first one, this means that we have -1 minus -1 cubed over 3. So that's our top for the first one. Minus, now we've got to use -2, so that's going to be -2 minus -2 cubed over 3. That's our bottom. And then for the middle one, plus, now we got in the middle, top minus bottom. This is going to be negative 1 plus 1 cubed over 3. Then we got minus positive 1 plus negative 1 cubed over 3. And then the last two, so right now we just did A, and then we did B. Let's look at C. We'll do C down here. Plus, now we have from 1 to 2, so that's going to be 2 minus 2 cubed over 3 minus 1 minus 1 cubed over 3. Okay, so this is that point where I'm going to pause the video, do all this calculation, a bunch of combining fractions and stuff, and see what we get. Alright, so something interesting happened here. As I was looking at my numbers, I came up with the correct area but with a negative value. So I think I might have plugged in some wrong values here, but I just want to show you kind of how I used wolframalpha.com to help evaluate that, and also show you some of the math. So plugging in the values and doing some simplifying, these are what I was coming up with, and it was coming out to negative 4. But the answer is really positive 4. That probably means that I just got my pluses and minuses switched up somehow. So let's show you also how this came up with Wolfram Alpha. So if you just type it in, we get plus 4 here, and again, that's that same kind of picture where it's showing the area but everything positive and hitting at 1 and 1 there. Okay, so there is that area, and that's the video. Use substitution. Makes you happy. Have a good day.